Hello, everyone. Welcome to the second session of Science Week celebration, right? So we are not celebrating science this time for a day, but for a week. But should we celebrate science just for a week or should we celebrate it every day? Tell me in the chat box quickly. Should we celebrate science just for a day or for a week, or that is every day we celebrate it? Every day. So I'm getting a lot of responses every day quickly. Yes. So the idea to take Science Week from day to week was that we don't restrict it to a day, but we think about it every day. So week is again just a symbolic thing. And as you know, we have several events planned for every day also. So it doesn't end for a day or for a week or for these short periods, right? So I'm so happy to see you all today with a lot of energy. And today it's a special session for the kids. And I know that there are many adults who are also part of today's session, but that's okay, right? See, I am also a child. I also have a child inside me. So I want to, although I am called as an adult, but I can also play. I can also explore things. I can also do some simple experiments. I can also observe. I can also question, right? So I'm sure there are many adults out there on YouTube or on Zoom. So please feel free to explore. We can also, and we should also give sometime this platform to the child inside each one of us, right? So today will be an exploratory session. I guess all of you are excited about it and you all have a lot of materials ready with you. So we will make good use of all these materials today and see how we can do a lot of experiments with these materials, right? So with that, let's get quickly started with today's session. I want to introduce you to Vyshnavi. So myself, Pankaj, I am from Seed2Sapling Education. And as you know, the Science Week, we are celebrating it along with the Academy Trust of Indian Academy of Sciences. Now, Indian Academy of Sciences is a body of more than 1,000 distinguished scientists from across the country and even globally. So we are very fortunate to have this event organized by the Indian Academy of Sciences, the Academy Trust, and jointly with Seed2Sapling Education. Right. So today for the session, we have Dr. Vyshnavi Ramesh, who is going to primarily facilitate today's session. So she is a PhD from IIIT, International Institute of Information Technology in Education Technology, and she has done a lot of work on this education technology. She has a lot of experience in personalized learning, early childhood education, and for the past couple of years, she has been outside and worked with a lot of school systems over there. And definitely, she is passionate about inculcating this philosophy of lifelong learning in all the students and everybody. I'm sure she herself is a lifelong learner. That's where you can inculcate that habit to other people. So yes, over to you, Vyshnavi.
Thank you, Pankaj, for that warm welcome. Let me take a minute to just share my screen.
And kids, you can turn on your videos today because it will be good to see you all doing experiments. Even on YouTube, please keep sharing your experimental observations, your questions, anything that comes to your mind. Yes, Vyshnavi.
Hi, everyone. It's so good to see all of you here today. Thank you all for joining us, both all of you here on Zoom and all of you on YouTube. We are so happy and so grateful that all of you have decided to join us today. We are looking forward to a really fun exploratory session. So before we begin, I want to extend a warm welcome to all the scientists who have joined us. Because there is a scientist in each one of us, right? There is a child in each one of us adults. There's also a scientist in each and every one of us. So a very, very warm welcome to all of the scientists. And before we start, something very important I want to share with you, all your rights during this session. So you all have the right to be wrong. This is very important. I want everyone to understand that it's okay to make mistakes. It's completely okay if you're not always right all the time. In fact, we are going to see that we are going to learn that being wrong is just the first step to learning new things, right? So you all have the right to be wrong. You all have the right to be you. There's no better person to be. So please be you and please enjoy it. And we are all going to have a lot of fun. You all have the right to enjoy yourselves and have a lot of fun as you go on this journey of learning, right? So a couple of guidelines for this session. Please remember to keep yourselves muted. We would really appreciate it if you kept your videos on, if that's okay, so that we can see you using the eyes and exploring along with us. But we do require that you keep yourself muted. However, not to worry, there are lots of other ways to participate. You can participate via chat, whether you're on Zoom or YouTube. We are keeping track of the chat and we are looking forward to all the interaction. Those of you on Zoom can also use the little emoji for a quick thumbs up, thumbs down on Zoom if you would have anything to share. And we are also going to be sharing a number of polls and other ways for you to keep interacting with us. So just because you're muted, that doesn't mean that there are no other ways to participate. So let's move on. So we had mentioned to you a few things that we would like for you to keep ready. So some of the things that you need to keep ready are some ice cubes. If you want, you can keep these in your freezer and I'll give you some time to grab them right when you need them. We need a couple of glasses, tumblers, cups, preferably transparent ones. Whether it is a tumbler or a bowl, either is fine. It's better if it's transparent. We need a couple of small plates, preferably identical. You might need a couple of spoons. And you definitely will need some salt. It would be good if you had a couple of other things like sugar and turmeric. And as you'll see, anything else you want. You will need some tap water at room temperature, not warm, not cold, not hot, just room temperature cloth tap water. And very important, you will need a small cloth to wipe up any spills. There may be messes. Messes are part of learning. It's also important to keep cleaning up as we go on, right? So today's session, as you all probably guessed by now, is all about ice. So all of you have seen ice in many different forms all around you. You may have seen ice cubes in your freezer. Maybe you have used those ice cubes to help soothe an injury if you have gotten hurt. You may have found ice cubes in your juice glass, or you may have had an icicle or a popsicle. You might have read in books about Eskimos who live in houses made of ice called igloos. Maybe some of you have seen movies about ice palaces. Maybe some of you, I see that we have people logging in from all over India and even outside of India. So maybe some of you live in really cold places where there are snowy mountains. So whatever it is, I'm sure all of you have come across ice, used ice in many different ways till now. And today we are going to explore a lot about ice. So one of the first explorations that we're going to do is help a little girl named Joy get to school. So Joy is a little girl who needs our help. Joy lives in a place that gets really, really cold during winters, and the sidewalk outside of her house is frozen. She can't get to school and she really wants to go to school. How can we help Joy melt her sidewalk and get to school? So first we are going to think like scientists and think, what do scientists do? Can all of you share in the chat box what you think a scientist would do to help Joy? I'll give everyone a minute or so to share their responses. I see a lot of really fun answers. Put her in a snowmobile. That sounds like fun. Burn fire. Research survey. All very, very interesting answers. I see an answer, use a sleigh. That sounds like a lot of fun. Scientists make some of the best toys for Joy. That's very interesting, Achita. We will be getting back to that sometime. So you see a lot of answers about salt. So I'm going to just remind everyone that Joy is a very young girl. She's probably like about 6 or 7 years old. She cannot use things which are hot. She cannot use things which are sharp. She cannot use things which are not safe for her. I see someone mentioning ice skates. I see someone mentioning flamethrowers. All such nice responses. I'm so excited seeing all these responses. The idea is messaged in a direct message to use a hair dryer because that's a little safer. It's a good thought. So now we're going to proceed. I see a lot of really, really useful answers here, and I bet Joy is going to be very happy to get so many such useful responses to her too. Mihir, that's a very interesting response that school is online, but you know what? Her school reopened for offline school and she is really, really excited to go to offline school. But those are all very interesting answers. So let's see what are some of the other things that scientists do. So there are a bunch of processes or skills that scientists learn to develop so that they can solve problems and answer questions, right? Probably the most important thing that any scientist does is ask questions. Scientists ask questions about everything. They ask questions about the sky. They ask questions about water. They ask questions about you name it. A scientist will love to ask questions about it. So the first thing that we do to solve a problem is ask questions. The next thing that scientists do is perform experiments. So what's an experiment? An experiment is a kind of a big word for something very simple. Scientists perform tests, simple tests called experiments that they use to find answers to their questions, right? Scientists also make predictions. A prediction is just a guess. A prediction is just a guess that scientists do to where they guess what will happen when they perform their experiments, right? For example, I see that some of you have guessed that by adding warm water, you are going to melt the ice. That's a prediction. Someone once predicts that warm water is going to melt the ice. So that's what a prediction is. After making predictions, scientists observe. They look around them, they try stuff out, and they use all their five senses to figure out what's happening, right? Scientists also choose variables. A variable is just something that you can change. Again, one of you have mentioned that you can change the temperature around the sidewalk by using a hairdryer. So the temperature around the sidewalk is a variable. That is something that is going to be changed. So a scientist gets to choose the variables that are going to be changed in their experiment. It's also very important to remember that scientists compare. Scientists see what is similar and what is different between two things, right? So now with all these new tools in our that we have learned about questioning, about observing, predicting, about making experiments, and about choosing our variables, how are we going to use all these tools to perform an experiment around the ice on the large sidewalk? Does anybody have any suggestions? Please share in the chat box. So I want all of you to remember that the sidewalk is really, really large. The pavement or the sidewalk, it's very large, and we cannot replicate. We don't have such a big sidewalk in our house. I don't know about you, but I certainly don't have such a big sidewalk in my house. So how can we try to pretend or model a really large sidewalk like that in our house? I see a lot of responses coming in. I see responses about things that we're going to use. I see some very interesting responses about sprinkling turmeric and sugar and and I see thermocol as a response. Make a miniature sidewalk. Yes, Vigyan, you're on the right track. And I see someone else is also on the right track. Take a sample of the ice on the sidewalk, Yashva. How do you guys suggest that we make a sample of the ice on the sidewalk? Or how are we going to model the ice on the sidewalk? Pages, Hiranmayi, Anushka, Mihir, and Sai Harshita. I see a lot of responses about using the ice cubes. So yes, you're all right. All those of you who said ice cube, that is one way that we can definitely test out whether how we can help Joy. And all of you who have mentioned other answers, such as making a model of the sidewalk, you're all right. These are all just different paths that we can take. So today, since we have the ice cubes at home, and since all of us probably have the ice cubes at home, we're going to try helping Joy by using the ice cubes. So we're going to perform an experiment using our ice cubes to help Joy. So next, what are we going to change about the situation to help the ice melt? Because Joy has been trying to melt the ice. She's been trying since 6 in the morning. She has been trying to melt the ice and nothing is working. So something needs to be added to help the ice, or changed. I see responses about the temperature. I see responses about sugar, hot water, salt, tap water, about changing the heat. All very good responses, guys. That is so helpful. I see a lot of responses about salt. So if you were a little kid, what do you think would be easier for you to handle? Do you think that it is easier for you to handle something that is hot or something that is at room temperature like salt? I see some of you are already deep into experimentation mode, and that's awesome. I see a lot of you are suggesting salt, so that is definitely one way that we can try, and we are going to try salt and a few other things.
So Vaishnavi, I just want to ask them, what about other things? You also have sugar, you also have water, you have some turmeric powder or any of those other things. Can you also use them or no? So other than salt, would you also want to use something else to make it melt faster or make it melt? Okay, so now you are saying we can try with sugar, we can try. Okay, great. Great, nice. Yes, continue.
See, many of you are also giving explanations, which I think is very important. I see Mihir, and I see Deepta, and I see a lot of people giving explanations on why they want to use salt. So I think that's very important. You guys are on the right track because you are giving explanations for your predictions. So that's great. So we are going to try adding something to the ice. As Pankaj rightly mentioned, we can try adding pretty much anything. We can add the sugar, we can add the turmeric, you can add pretty much anything that is readily available to you. So in our experiment, we are going to add a variable. So like we talked about, a variable is basically anything that we can change in our experiment, right? To see if it helps solve our problem. So today we are going to try adding a variable like salt to the ice cube to see if it melts faster. Now, there's another little tricky issue over here. How will we know whether the salt that we are adding will help the ice melt faster, right? So we're adding salt to one of the ice cubes. How will we know whether that ice cube is melting faster or not? How will we know whether it's helping or not? I see some of you are sending me a direct message. I see some of you are sending messages about observing and comparing by seeing the time. I see a lot of you are talking about observing and watching the results of the experiment, and I see many of you bringing out that you need to compare. So what do you think we should compare it to? We're going to add salt to some of the ice cubes. What do you think those salted ice cubes need to be compared to? I see Nambi says, and Tejas and Hiranmayi say that we should compare it with another ice cube. What about the other ice cube? Do we need to add something to the other ice cube? I see some of you say that we need to add other things to the ice cube, and I see that some of you say we need to compare it with the ice cube that have no salt on them at all. So once again, you're all right over here. And one of the things that we need to remember when we are making experiments and is that we always need we always need a variable that we can compare our to, right? So we're adding salt to one of the ice cubes. What do we compare that to? How do we know it's melting faster? So we are going to use another ice cube without anything added to it to make sure that to check whether the salted ice cube is melting faster. Okay, so now we have made an experiment design. We have gone through the steps of making an experiment design. We have chosen our variables. We have made our predictions, and we have also decided what we are going to compare the salted ice to. Right?
So somebody from YouTube is saying, Pooja is saying control. So that's actually a technical word, very nice, that you need to have a control where you are not adding salt. It's just the ice cube lying there. Very nice.
Nice. I see Aditi in the Zoom chat is also mentioning the same thing, that the ice cube that you're not adding any salt to is called a control variable. So basically what that means is this variable controls your experiment, right? So without having the ice cube that doesn't have any salt added to it, or without the control variable, our experiment is not going to have much of a direction to go into it. So that's why it's very important that you have a control variable in your experiment. I see Archita, Meghna, a lot of people on the chat have also mentioned control variable now. So that's very nice that all of you are already thinking scientifically and you're thinking like scientists to solve this problem.
You have so many little scientists today.
Yeah, we have so many little scientists. It's so nice to see. So now the next step in our experiment is to make a prediction. So now in the chat box, we will share a link to a poll. If you have a phone with you, you can also scan the QR code on the screen and you can make a prediction on what you think is going to happen when you add salt to ice. We will be sharing the link in YouTube as well, and the QR code is also there on the YouTube screen. So we welcome all those of you on YouTube to participate as well. I'll give all of you a minute to answer the poll over here. And once you've answered the poll, you can also quickly grab your ice from the freezer if you haven't gotten it yet, because it's time to get cold playing with ice. You will find the link in the chat box as well. Both Pankaj and Chintan have shared it. So we have just given you a lot of different ways to go. By giving you a QR code, we have given you a URL. We have also told you can visit menti.com and type that code. As long as you do any one of these things, you're good.
Let's see the results, Vyshnavi.
Yes. Let's give.
Wait. Don't get the ice now. Let's see what are your predictions. I assume this is everybody saying ice salt will make it melt faster. I'm curious to know. Ah, nice. Yeah. Can you share that result?
Are you able to see that screen, Pankaj?
Yeah.
Okay, great. So here are the results of that are coming in from all of you. How will adding salt to ice change the rate at which it melts?
So somebody on
Who
real
haven't answered yet, I'm not reading this out loud just yet. You can all please answer, and you can make your own predictions. You don't have to see the predictions that your friends are making. I'll just give maybe 10 seconds more.
So somebody on real me C2, I don't know who is that person. So tells very nicely the reason, one of the reason also.
Thanks for sharing. I see the name to be Real Me C2. That's a very nice explanation for your prediction. Dissolving, for those of you who are on YouTube, maybe I will just read this out loud so that you can also see. Dissolving salt in water lowers the temperature at which water freezes or at which the ice melts. Salt, when placed on top of the melting ice cube, will dissolve in the little bit of water that melts first, and the dissolved salt lowers the melting temperature of the ice it's in contact with. So that's a very nice detailed explanation. We will see, we will do the experiment, and we will see whether and observe whether this is what's actually happening. So, right, I think all of you have now gotten a chance to answer the poll. I see that the pace of answering also has come down, so maybe we will just proceed now. Yeah, so we see that most of you say that adding salt will help the ice melt faster. So let's go back. Let's go back. Now I see that most of you, those of you who have your videos on, already have your ice with you. So I'll stop sharing my screen for just a minute. So for this experiment, you're going to need 2 ice cubes. You'll need 2 identical plates, and you will need about 1 spoon of salt. Okay. I'll stop sharing my screen for a minute so that I can just demonstrate and show you once myself. Here I have 2 ice cubes, 1 on each plate. Both the plates are exactly the same. My ice cubes are also exactly the same size. And I'm just sprinkling salt on just 1 of them. So I've sprinkled about a spoon of salt, this kind of spoon of salt on 1 of them. I'm just going to keep it aside for a minute and give all of you a chance to do the same. All of you on YouTube also, I hope you're able to participate with us.
Yes, YouTube is very active.
That's wonderful. I'm so happy.
So there are many things which are coming about sugar and turmeric. So many people are trying to predict that with turmeric it will not be the same, or with sugar it may not be the same, and also. I see that some of you have mentioned that your ice has melted. I see one of you is asking, ma'am, please tell if it's fast or slow. No, this is an activity for you all. You are all going to tell me whether it is fast or slow. I see Advika says that salt hastens the melting of ice. Why? I would like to know what is your reasoning for that. Suparno says his salted ice is melting very fast. I see some of you don't have access to ice, and that is okay. These are, even if you're not able to do the exploration with us today, now you know, next time when you have some ice with you, you will all be able to do it. So it's okay even if you don't have ice with you today.
Some of you, you can definitely do this science days, not for just one day, right? You all said science day is for every day. So you can definitely do this activity anytime you want. I see many of you are sharing your screens, showing that the ice is melting quickly or melting slowly. A lot of you have predictions on why that's happening. So I think by now most of you have gotten a chance to try out this activity. So once again, we have another poll for you. We want to hear from you about what happened, what did you observe. So again, just to recap, observe means you're going to use all your senses to see what happens, right? So some of you have mentioned that you feel like salt is heating the ice. So this is a situation where we are observing not just with our eyes, but we are also observing with our sense of touch to see how hot or cold something is. So we use all our five senses to observe. So you can the link will be shared in the chat box. Chintan has already shared it. You can visit the link in the chat box and answer the poll, or you can scan the QR code once again. So actually, the answers we are getting, I am sharing my screen, and the answers we are getting are very interesting. Once again, it's important that you do not worry what your friends are answering or what results your friends are getting. Each of your results are valid, and you have the right to be different and unique, right? So I see that some of you have answered that the ice without salt melted faster. Around six of you out of 55 have answered that the ice without salt melted faster. So slowly, that number is also increasing. Does anyone have any predictions or guesses why it might have happened like that? Why do you think that the salt with ice melted faster? Many of you have given answer why adding salt to the ice and water mix caused it to melt faster. But I want to know what is your prediction? Why in some cases the ice without salt melted faster? Dhruti has mentioned that she has used rock salt. So that is also a very important point. Sometimes, even if we are choosing the same, we feel we are choosing the same variable, that is salt, but actually it might be different. Some might be using rock salt, some might be using table salt, some might be using Himalayan salt. It might be many different kinds of salt. Some of you are sending me direct messages. You are absolutely welcome to send messages to the whole group so that everyone can see your lovely answers. Bhuvan says when ice melts, water and ice coexist. Because the salt particles make it harder for the water particles to freeze back into the ice that is in contact with dissolved salt melts faster. That's a very detailed explanation for your observation, Bhuvan. Thank you so much.
Vaishnavi, I have an interesting observation here. In your poll, 14 of them are saying that the ice without salt is melting faster.
Yes.
So that is something interesting to see. Why are we seeing this dichotomy?
Why, those of you who are seeing that the ice without salt melted faster, do you have any predictions or guesses why that is the case?
And what do we do now? Because we are not getting, see, finally everybody is using ice, everybody is using common salt. What can be the explanation of this difference in experimental observation?
Tejas and Kiranmai have a very simple comment for that, and they have made a good comparison also there, that the ice cube on salt melted faster because their ice was not frozen well. So that's a very good explanation, because they have observed and analyzed why they think that this dichotomy has happened in
So
their case.
Shreya from YouTube says that adding salt to the ice decreases the freezing point, which is why the ice cube with salt melts slower. So that is another very interesting thing as a follow-up experiment. So right now we are checking for melting. Maybe some of you may want to do how is it freezing. So who all want to try out to freeze the water, normal water, salt water with lot of salt, less of salt, and see how much time it takes for freezing. So who all want to try? Can you just type yes in the chat box? Who all want to try freezing of salt water? Because we are trying to do with melting with the help of salt. Okay, so we are getting so many yeses everywhere. So that's an interesting
I have
thing.
another interesting question for you guys, and this is not for you to answer right now, but for you to think, and you can always get back in touch with us. There are places in your life that you have seen other things added to liquids and being frozen. And how they all freeze differently. Maybe you can think about other things that get frozen and how they get frozen, not just water, but maybe some things that you like to eat or drink and how they get frozen. Just something to follow up and think about, and how these things melt and so on. So I think everyone has gotten a chance to answer the poll now. And those of you who have seen this different observation that the ice without the salt has melted faster, I'm looking forward to seeing all your predictions on why this is the case, and why you think this has happened. You are most welcome to share your responses with us even after the session. We are actually looking forward to it very much. So please go ahead and do that.
Right.
So I see that many of you have already answered that the ice with the salt has melted faster. So now we'll for the so that we can do some more explorations, and we would really like to spend more time on this exploration, and maybe we can do so after the session as well. But we will have to give some sort of observation and conclusion to the first exploration that we have done, and see how we can help Joy, right? So what did we do in this process? First, we have designed an experiment to answer our question. The question was, how can we help Joy to melt the ice? And we designed an experiment by using the ice cubes, which are small and readily available to us in our homes. We predicted that adding something, a variable, to the ice will help it melt faster. And in this case, many of us have chosen to add the variable of salt to our ice. And many of us have also chosen to add the other things available to us, like sugar and turmeric, also to the ice, and see what happens. So we have observed what happens after we add the salt to some of the ice. We added turmeric. We did not. And most importantly, we realized that we need to keep 1 cube of ice without adding anything to it. We need to keep that aside. And does anyone, do we all remember what we call that variable that we keep aside without making any change? The control variable, right? So we kept one ice cube as the control variable. Yes, I see many of you have remember that word, control variable. So we keep aside 1 cube of ice as the control variable. And finally, we observed that the ice melts faster with the salt added. In fact, even the one that I have with me over here is completely melted, but the one that I did not add anything is I still have a little bit of that ice cube left. So we realized that Joy can add salt to her sidewalk in order to help her get melty ice, and then she can get to her school, her offline school. So now many of you have already done this, but what else can Joy add to the ice? And this is not limited just to the turmeric and the sugar which you have brought, but anything around your house. It can be anything. Many of you have mentioned some very interesting things, like a hair dryer. And one of you has mentioned to me in direct message that by using hair dryer, even a young girl like Joy can actually use a hair dryer. So many interesting responses are coming, and I'm eager to hear more about what else you think Joy can do to add to the ice to help her get to school. So now we are going to do another very interesting exploration. So for our next exploration, we are going to get 2 cups of water, as it is shown in that picture. We are going to have 2 cups of water, and we are going to add salt to one of the cups of water. We are going to add just about 1 or 2 spoons of salt to 1 cup of water, and we are going to predict which of these. We are going to add 1 ice cube to each of these cups.
Don't start this experiment. Nobody starts this experiment. Okay, just hold on. Yes,
just hold on. We are still on the prediction stage. We are just telling you what we are going to do. Just hold on. I see most of you are just holding on and you're waiting. So thank you for that. So this is basically what we are going to do. Before we go on, I want you all to predict which one is going to melt faster. Is the ice cube in the salted water going to melt faster, or is the ice cube in the plain water, the unsalted or the normal water, going to melt faster? Once again, the link is shared. You can use the scanner and scan the QR code and share your answers. This time, I am not going to share the screen until for the next 30 seconds or so that everyone gets a chance to answer so that we hear what each of you are thinking or predicting. Again, so there is 2 cups of water. One of the cups is having salt added to it. Other cup has nothing added to it. Both the cups are in room temperature, where in normal temperature, and each cup we are adding 1 cube of ice. Which ice cube is going to melt faster?
So now instead of adding the salt, we are adding ice in the salt water and normal water. So let's see. There is normal water, there is salt water. Which will make it melt faster? Yes.
Naman mentions assuming equal temperature, and I want to bring out that is such an important point, that we assume equal temperature, that it's very important to state all the things that we are assuming, because supposing there is 1 cup of water which is kept in a cold place or kept in the fridge, or 1 cup of water which is kept in outside under the sun, the results will be very different. So that's a very good point to make. Meghna, yes, normal one, I'm sure. Yes, it is. And I see some of you have predicted salt water, some of you have predicted unsalted water.
Right. Can you go to the poll results?
Yes.
I'm curious to see this. So many of them are writing in the chat box. It will be okay.
These interesting results are very interesting, because I see that there is many people with many different predictions. So actually, that is what makes all these experiments more interesting, right? Because we have so many different predictions over here. Now we can predict which one is going to, which one of these predictions is actually going to happen, at least for in our case. Maybe in a friend's case, it might be a little bit different. I'll give 10. I think most of the responses have come in. So we will go. I see that out of around 100 people who have answered, we have about 72 people who feel that ice will melt faster in salted water. 23 people are saying that ice will melt faster in unsalted water, and 8 are saying that there will not be any difference. So these are very interesting predictions. I can't wait to see how this exploration goes.
Let's start with this exploration.
Yes, I'm very excited about this exploration. So
yeah.
Let us get just a second. Right. So here you have to get ready with two cups of water. And I'll go back here just so that you can see the picture. You'll need 2 cups of water. Each cup you will add the same. You will just add 1 cup of tap water. You'll just add 1 cup of tap water. And as one of you had rightly said, both of them should be in the same temperature. And to one of the cups, we are going to add 2 spoons of salt. Maybe I will just stop sharing my screen for just a minute.
Can you show your 2 cups of water, everyone? One with salt, one without salt. Okay. You add 2-3 cups, spoonful of salt, right? Everybody has added 2 to 3 spoonful of salt. Very nice. Okay, great.
You can all see the picture on the screen, right? So you can see a really big iceberg, which is there in the sea. It is in salted water. So we are trying to model such a scenario over here. So here we have one, you can see that I have 1 cup with some 2 spoons of salt, 1 cup of plain water. Now I'm going to add one cube
of ice, yeah,
to each. So I've added 1 cube of ice. I'm just going to set it aside now. And I can see that many of you are also doing it. I see that some of you need to go and get some more ice cubes. Deepta, that's a very nice question. Why does water turn milky when we add salt? She asks. It's a very nice question. Do you have any guesses why it is turning milky?
So this is another very interesting thing, right? While we are exploring salt, ice, all these things, Deepta was very keenly observing if there is any other interesting thing, and she has this another question that water is actually turning milky just by adding of salt. So excellent, Deepta. I'm just so happy with this extra observation, extra question. So I guess Sai Harshita, you don't have to add water on the ice. You take the ice and dip it in water. Vyshnavi, maybe you can show that video. Or
yes. Just a second, I'll share the screen once more.
Yeah, or maybe while you can. So you add one salt in each glass of water. Add the salt, add the ice in one in each of the glass. Okay, so Haidar is already saying that ice with normal water is melting faster instead of salt water. Okay, so something interesting happening for Haidar this time. What about others? Haidar says it is melting faster in normal water.
Also curious to hear if the YouTube folks have any interesting responses.
So Shabbir and Haidar both has. Advai says, ma'am, when will you tell why?
Advai, that is for you to tell us. That is for you to tell us why.
So Sai Harshita has another very interesting observation, right? Why does ice float on water? So while we are melting and doing all those things, she has another interesting question. Why does ice float on water? Very nice.
Very nice. It's so nice to see all these lovely questions.
It's melting faster in normal water, melting faster in equally melting faster in YouTube participants. What do you see? Melting faster in ice, salt water, normal water, both same.
Lavanya says ice with normal water melted faster in a difference of 30 seconds. So that is great that you're measuring it, Lavanya. That's very accurate, and it is nice that you are using a timer and checking that. Naman again has a very nice explanation. I'll read it out loud for the YouTubers. Salt water freezes at a lower temperature than the 32 degrees F at which fresh water freezes. The difference between the air temperature and the freezing point of salt water is bigger than the difference between the air temperature and the freezing point of fresh water. This makes the ice on salt on it melt faster. That's a very detailed explanation, Naman.
So we have another interesting explanation from YouTube. I'm just pasting it in the chat box from Akshat. When added to ice, salt first dissolves in the film of liquid water, then that is always present on the surface, thereby lowering its freezing point below the ice's temperature. So there are multiple explanations coming over here. Let's take the observation. What did everybody get? Let's run the poll again in a while.
Yes.
Let them at least share their observations.
So we have gone through these directions already. So on this over here, we have a small, let's first do the observations before we go through the video. So once again, let us see everybody's observations. The link is shared by Chintan in the chat box. Welcoming again all those of you on YouTube also to participate.
So somebody messaged me privately that, sir, my ice melted slow because it was still and was not moving, and the other was moving. So that is another very interesting variable to try. What if we stir the ice, and what if we just keep it still? So we can keep it still, not move it at all, or we can just move it. So many interesting further explorations leading up.
Very nice to see that all of you are making these predictions and observations, but not only that, you are trying to explain why is it happening like this, why is it that I guessed like this but it is happening like this. This is probably the most exciting thing for me in this whole presentation.
The ice in normal water dissolve 40 seconds faster than the one in salt water. Sherin says in YouTube, sir.
Very nice. So maybe I will now check the results of the poll.
I'm curious to know. Okay, wow.
Very nice to see this dichotomy because now it is exciting. Now the story gets very exciting. So 43 out of about close to 85 who have answered are saying that the ice melted faster in salted water. 32, just a little less than half, are saying that ice melted faster in unsalted water. 3 are saying there is no difference. Any of you have any guesses of why this dichotomy is happening? Meaning, why is it that different people are getting different answers, and why we have gotten 2 to 3 groups of different answers?
So how can we explain this differences in observation? That is another very interesting part of doing experimentation, right? Today we did something, we found something, and tomorrow the results are something different, or I did, then it was different, and when my friend did it, it was different. So how do we resolve? This is very important aspect of experimentation. How do we resolve this? How do we find any solution for this? The environment is different, okay? Because all salt and ice are not same. Interesting.
That's a very interesting. So supposing that you and your friend are sitting next to each other in the same room, you are doing this together, either in your home or in your school, you're doing it together. And you got 2 different results. Do you think, what would be your guess? Do you think there will be a different result, or do you think that
amount of salt may be lesser? See, so many.
I have a direct message telling me, ma'am, please tell the reason why ice melted faster with the salt added. But the answer is going to come from all of you.
Silly.
Very
so
nice.
Many reasons. So many results.
Let me refresh it.
On YouTube.
Have answered the poll now.
So many reasons coming up here.
Though the number of answers in the poll is increasing, we are still having two groups which are maybe 60%, 40% like that. So we still see that dichotomy in the groups. Ananya has a very interesting observation that the unsalted water gets normal, but the salted water gets cold. It's very nice that so many of you are getting other questions and observations after doing this experiment, like about the temperature of the water and about the color of the water, like it turned milky and so on. Just like a balloon in one and multiple nails, ma'am, salt water and a pinch of salt will dissolve the ice faster. That is my guess, says Yashva. I am curious to hear why is that the prediction which you are making. Others says we need to do this experiment many times and take an average of all the results. That's a very interesting way to approach that, others. I think that's good. So, what about the variables in each of the experiments? What do you think that the variables have to be changed, or will you keep the same variables? Will you change the amount of salt or amount of water? Tejas and Hiranmayi say even if they're sitting in the same place, maybe one friend has added little less or more salt than the other friend. So if you're saying even if you're sitting in the same place and if you feel everything else is the same size of ice cube, same amount of water, still there might be some small differences. So that is why you're getting the difference in the answers. Right. So I see a lot of very interesting answers coming in about not only why you're seeing ice melt faster in one kind of either salted or unsalted water, but also many of you are thinking a lot about why you're seeing that difference in results. So I think that is really wonderful that you're giving that some thought. So I'll just show you a quick video of when we did this experiment about how it went. So here we have 2 cups of water, 2 spoons of salt have been added. As one of you pointed out, that cup of water is looking a little bit milky. And we add 1 ice cube to each of them. Take out the ice cube from each of these cups of water. At the same time, the water without salt has a much smaller ice cube than the water with salt, as you can see over here, meaning that the ice cube in the unsalted water has melted more. But this is just the result that we got. Since all of us have gotten very different results, it's now time for each of us to think why we each of us got this result and try to find an explanation. So we have already gone through the poll. So now we have done one more exploration. Now we try to see whether ice is going to melt faster in salted water or unsalted water, right? So we made a prediction first where it will melt faster, and then we performed an experiment. Then we compared the ice melting in 2 variables. One variable is the salted water, one variable is the unsalted water. And we observed to check whether our prediction was correct. Was the prediction correct? In my case, in the case when we did this experiment, the ice did melt faster in the unsalted water. But in many of your cases, it melted faster than salted water. How do we explain this? I will leave all of you with this thought, something to think about, and I'm looking forward for this discussion to keep continuing even after this session. Right. So now we're going to come back to our ice cubes. This time we are just going to be making some observations. So I'm going to bring back one of the ice cubes and I'm just going to observe it. I'm just going to look at it. I'm going to feel it. I'm going to touch the ice cube, see how it how it is on the outside and inside. And I'm going to make some observations. And I have a lot of questions about this ice cube. I have so many questions I want to ask about this ice cube. So even you must be having so many observations about the ice cube and so many things you want to know about the ice cube, so many questions you want to ask. So we have a small tip for you when you are thinking about asking questions, right? Sometimes we all have a lot of questions. We have so many questions in our mind. We do not know how to get all our questions out, right? So if you want, you can use this little tip to answer questions.
So everyone, we can ask them to get 1 or 2 cubes of ice and just observe, yes, play with it.
If all of you have some more ice with you, if you need to get from the freezer also, you can just take 30 seconds and go get some more from the freezer and just get back one of your ice cube. You can hold it, you can play with it, you can see what happens when you hold it and so on, right? So I'll give you a small example. I'm holding an ice cube in my hand. I see lots of little designs inside the ice cube. I think that there is something trapped inside the ice cube that is causing all these designs. I wonder how these little designs got inside the ice cube. I wonder what it is. Is it some more air? Is it some more water? I don't know what it is. But this is just one of the many, many questions I have about these ice cubes. So now I'm looking forward to hearing a lot more questions from all of you. There is no limit to this asking questions, both on YouTube as well as on Zoom. I'm looking forward to hearing lots of questions from all of you
So
about the
feel
ice
free to
cubes.
ask any question. So you are trying to answer what Vyshnavi just told, that air bubbles, crystallization, but try to come up with your own observation. See, Ananya has a very nice question. Why is ice cold? You may have any such very simple question. Just looking at the ice, let's see who all has any more questions. Let's focus only on questions. Let's keep asking as many questions as we can. What all
The other
questions
thing
come
is,
up?
you don't have to know the answer to your question, right? This activity is not so that you know the answer. We are asking questions because we don't know the answer. So you don't have to know the answers to all your questions. In fact, if you know the answer, you may not actually be asking the question. And there is no there is no right or wrong in answering questions. So you feel free. You can ask as many questions as you want. And my example for you was just an example of asking a question. I need not hear the answer to the question, as you rightly said. See, a question: will the results change if we use distilled water? Why are there bubbles inside the ice cube? When we touch ice, why our fingers become numb?
Wow, nice.
What makes ice to make design?
Oh,
Why is ice slippery?
excellent, excellent.
Do we have any interesting questions in YouTube also, Pankaj? Please feel free to share.
Yeah, we will get some questions. Why do the icebergs do not melt in sea? Because there is seawater also salty. Okay, so somebody is trying to interpret that. Okay, so that's, in fact, that has huge implication for our climate change. We can discuss that some other day. But center is thick and side is transparent. Very nice observation, Manjula.
Very nice observation.
I'm reading it
If
also on
hot
YouTube.
water freezes, it's transparent. If we freeze cold water, it's translucent. You want to know why that is?
So Prashant has a very fundamental question from what we did today. If the ice with sprinkled salt on it melts faster, then how does the ice with salt melt slower? So added in salt water, I guess he means. So we will discuss. So this salt and salt water thing, we will discuss it later today. We just want to get as many questions from you before we go back to our salt explorations and discussions from there. We will discuss some more interesting explorations that you can do further with salt and ice. But let's come up with many more questions from you all. Yes, so the temperature of salted water slightly changed. Why? Yes, Vaishnavi, you can read those.
I see some messages coming in the private message. Also, feel free to put your messages in the main chat to everyone.
Very nice question.
Very nice questions. What will happen if we add sugar instead of salt and then add the ice cube? That is something that I'm sure all of you are going to try soon after the session itself, because now you're also curious about it.
Right. Suparna has a very nice question. Why does it stick to our tongue? So the ice, when we put it in the mouth, why does it stick to our tongue, or even sometimes it sticks to our hand? Like, very frankly, I may also not know many of the answers, but we can all ask questions still, even if we don't know the answers.
Why does the ice take the shape of the container?
Wow.
And why is ice floating in water? Very nice questions. Very, very nice questions.
Why hot water gets freeze faster than cold water? Where the design comes in the ice.
Some of you are making predictions to answer each other's questions also and giving explanations. So that is also very nice.
Oh, why can't we eat ice beside water in everyday life?
It's a good question. Why do you think so?
Very nice.
Amrita says, why when we put ice in the mouth, then why the smoke will come? An interesting observation.
Parinita also has a very nice question. Why texture of ice is rough when salt is added?
Very nice question.
So even while doing that salt exploration, there are people who are observing what is happening very carefully.
And I see that you're
nice,
using
Simon.
all senses to observe. You're using
Yes.
sense of touch, sense of sight, all the senses you're using.
Why hot water gets freeze faster than cold water? Okay. So, see, so many questions now. Who is going to answer these questions to us? Who is going to answer all these questions to us? Now, anybody has an answer to my question? Who is going to give us answers to all these questions? Yes.
Mohan asks, are snowflakes and ice the same?
Nice.
Very nice.
Science. Okay, what is science? We yesterday heard from the horse what is science. Our distinguished professor answered, right? What is science?
Yes.
So we can experiment for ourselves. Very nice, right? So nice. So many questions. So what do you think? In this world, there are more questions or more answers? Are there more questions or more answers? Which is more, question or answer? Both. More questions, both questions, both. Right? So what do we do with these questions then? Because Google also may not know, right? Because there are more questions or equal questions. Who is going to give the answers to all these unanswered questions, which probably nobody knows the answer? Who is going to find out these answers? So is it somebody else or is it us? These scientists are somebody else or is it us, ourselves? Yes, me, ourselves. Okay, there are so many more questions coming in. Vyshnavi, let's quickly move on to the next part. I guess we have triggered them enough to ask. We have triggered them enough
to introduce them to what is there on the next slide, isn't it, Pankaj?
Yes, absolutely.
So we have something very exciting for all of you. Now all of you have become, you're all scientists with us and you have all started asking so many questions. So we have made a festival just for you all to answer questions. Many times you might have had science fairs and you might have had quiz programs and you might have had projects where you show some of your very nice project. Here, we want to hear all your very nice questions, right? So now today during our activities, we have made many observations about the ice and what happens when we add salt. And that made all of you so curious. So many of you started asking more questions where once you saw what happens when you add the salt to ice. And that gave rise to so much of pondering and probing, and it made you want to explore more by adding other things like turmeric, sugar, and so many other things, right? So now you're all in the mood to ask questions. So sometime later this week, you will be joining more and more sessions with us during Science Week, and we are going to be having a contest just for you all to answer questions. We are going to you do not let me say again that you do not need to have the answer to the question. In fact, we don't expect you at all to have the answer to the question. We just want to hear your questions. But we expect one more thing other than just the question is your prediction. What may be the answer and how will you find out the answer? We don't want the answer, but how do you plan to find out the answer? So that may be interesting. See, Einstein once said very nicely, okay, so I have no special talent. Now, this is coming from Einstein, whom we all feel that, okay, he's a specially talented, but he says, I have no special talent. I am only passionately curious. That's all. So are we also not, all of us, in fact, are we all not passionately curious ourselves? Right? So all we have to do is to just put our question in that form. That's all. And that's where most of the things in science starts, not in the understanding, not in the knowledge, not in the information, not in the laws, not in the theories, just in the questions. Or the questions may also start from our careful observations, which many of you had today. Yes, Vyshnavi. So yes, we are very excited. We'll share with you some more sessions that will be happening. And later this week, we will be announcing how you can all participate in the Quest Fest. And we are looking forward to seeing all your questions. So we'll spend just a couple of minutes over here. Maybe this we can do after the session also. We would like to hear from you. What did you all learn from this session? And we want to know what you would like to explore further. Pankaj has shared in the chat box the feedback form for the session. So please share what you felt about the session, what are your reflections, and what you would like to what feedback you would like to share with us in the feedback form. The link is shared over there. You can definitely continue sharing this even after the session.
Right. We can quickly move on to the other part.
Yeah. So we have a bunch of upcoming talks during Science Week. It will be Science Week started yesterday, and we will be having talks all through the week until next week on Sunday, 6th of March. So tomorrow we have two very interesting talk by our distinguished professors and eminent scientists. We have a talk about how primes keep secret. I will keep the content of this talk a secret, but the talk is by Dr. Kaninika Sinha from the Department of Maths in Icebergs, Pune. We also have a talk from 6 to 7 in the evening. You will receive the details via email since you have registered, by Professor Pradeep Thalapil from Department of Chemistry, IIT Madras. He will be speaking on science, technology, and innovation for sustainable clean water. We have, for all the teachers who have joined us via YouTube, we have a couple of sessions for teachers on how to bring about the joy of science in class, and the other session is how to bring about the joy of maths in class, especially from Seed2Sapling Education, just for all of you. We have a very interesting and exciting talk by Professor Rohini Godbole from the Center of High Energy Physics in IASC. She will be speaking on the overview of particle physics from the heart of the matter to the edge of the universe. So many of you had so many questions in the beginning of the session about space, and I think that this would be a very exciting talk for all of you to join and participate. And we will be wrapping up the week with a special, with a student special. Again, I hope to see all of you there during that session. We will be exploring the magic of maths by using paper folding. That is again targeted towards students like all of you. So looking forward to seeing all of you there. We also have a program called The Joy of Learning. Pankaj, would you like to give us an overview of the JOL program?
For all the teachers, there it will be a separate course for science teachers and a separate for math teachers. And it will go on for the next 12 weeks. So through the summer vacation, this course will happen on a weekly basis. We will have one session, and all the details will be shared after the science week is over. But the idea is, let us as teachers, we experience these processes like today what we did, right? So once we experience, and then we will discuss ideas and ways and means to implement it in our classroom with our current constraints that we have. We may have to finish curriculum, syllabus, all those things are there, but at the same time, we should not miss out on this joy component, and more importantly, this important process skill components of science, which is what science is all about. So we will discuss all those ideas about classroom implementation challenges with the teachers through these 12 weeks. Yes, Vyshnavi.
Thank you, Pankaj. So thank you all for joining.
The session is not getting over yet. So because there are so many questions coming from that salt. So although this is a thank you for all these formal part, but we will get started with this informal discussion on our salt still. Yes, Vyshnavi.
We have a few more. We have one more informal discussion. We wanted to keep that towards the end in case we have time, and we do.
Because many of you asked, right, that why with salt it is melting faster, but in salt water it is melting slower. So what may be the reason? So we thought we will spend some time discussing that. Who is curious to like just experience further on that phenomena, that in salt it is melting faster, in salt water it is melting slower? Who is curious to know more about it? Just okay, so
do a thumbs up. You can do a thumbs up on.
I get a lot of responses in the chat box. Yes. So let's go on from here.
Sure.
Suddenly the number of people are increasing even in YouTube. So I guess many people are curious why, what is happening exactly. Right. Yeah, we can conclude that. We can conclude that part. Slide, Vyshnavi.
Sure. So for those of you who want to conclude the main portion of our event today, we'll just recap quickly what did we do today. So we asked a lot of questions. We asked a lot of very exciting, very nice questions. Nice to see all the curious young scientists. We designed an experiment to answer our questions. We learned how to choose and compare the variables, right? We learned that we must keep 1 cube of ice without adding salt as the control variable. We made a lot of guesses called predictions, and we made observations to see if our predictions come true. And I think all of us had a lot of fun playing with ice and adding different things to ice and exploring with ice, right? So that is basically what we did today. And I'm curious to hear what all of you felt about today's session when you fill up the feedback form. So for those of you who are interested, we have one more exploration that we can do today, right? We were all wondering why is the ice flow. Many of you asked why is the ice floating, and we were wondering why the ice in the fresh water is melting faster. That is, the water without salt is melting faster than the salty water, and so on, right? So here we have a picture of an iceberg, and we are going to try to make a model similar to how we did the activity with the Joy's sidewalk, where we used the ice cubes to model the sidewalk, right? Many of you rightly suggested that we can use our small ice cubes to model the sidewalk. So similarly, we want to think how we can model the iceberg, which is floating in a river and versus floating in the sea. So any of you have any guesses how we can model this?
Which
So
is
what,
that? Yeah.
any predictions that we have? So one thing to remember is that both the iceberg as well as the fresh water as well as the salted water are all, until we do anything to it, they're all color. They all don't have any color. They're all the same color. So how are we going to make some sort of a model?
So we are getting multiple responses. We can put ice in salt water. We can use an ice cube. So that's a nice thing that many students are already thinking, that we can simulate some of these very big complex phenomena using simple things at home. So see, we don't need a fancy experimental lab, any experimental setup, any expensive instrumentation or anything, right? We are doing complex experiment on very complicated phenomena of nature using salt, sugar, ice, or the most simplest of the things available, easily available with all of us at home. So yes, Vyshnavi, can you just go to the next slide?
Gauri says, Gauri is actually bringing us to our next slide by saying we can use ink for the ice cube.
Oh, nice, nice.
Very nice, very nice.
Nice. So this is what we did precisely. Okay. So now instead of using an ice, we can use a colored ice. Now this is something you don't have it right now, but what about just making a colored ice today? And by today night or tomorrow morning, you can try to use colored ice instead of normal ice and try to put it in salt water and the normal water, right? So in this image, so this is the left side and this is the right side. So what do you think? Which one has salt water? The left side or the right side? What do you think? Which one has salt water? The left side or right side? One has salt water, one is normal water. What do you think? Which one is salt water, and why do you think that is salt water? If you say, some are saying right, some are saying left, why do you think that is salt water? Why do you think left is salt water, right is salt water? Many of you are writing left and right, but can you state the reason why behind your prediction of left and right? So why do you say left is salt or right is salt? So in this image, so this is the one which is not spread out because salt settles down. Okay.
I got a direct message saying from Pavan saying that salt water disperses color faster.
Okay. Okay. Water occurs convection current. So that's why they say right. Okay. Right, because it is not dissolving, because at right freezing temperatures lower down. Okay. Iceberg doesn't melt in sea. That's why Nishta says right. Excellent. Wow. So many interesting things. So
Meghna has used some of her conclusions or observations from the previous exploration to make a prediction here. She says left is salt water because it is milky.
Right. Okay. So let's observe that video. Vaishnavi, can you just run this as video? Okay. Let's see this. One has salt water, one is normal water. Now, what do you think? In that same order, left and right. See, in one, all the color is flowing down. In one, everything is staying at the top. What do you think now? Jasbir says because of density. So we are getting a lot of active participation on YouTube. So I'm so happy seeing such active participation from YouTube and from Zoom both. I'm sure that there are many teachers and many other science enthusiasts who are watching this session. So science definitely is not only for students or only for some people working as researchers, but it is meant for everybody. And all the time we keep doing things unknowingly, which makes us more logical. So yes, see, in one case, when the ice was melting, it went down. In the other case, it did not went down. The melted ice actually stayed at the top. Okay, so this melted water of ice in fresh water, so this is fresh water, it is sinking. Why is it sinking? This is fresh water, and the ice which was melting, that sank down. Why do you think that has happened? And this is salt water, where after melting, the ice is still at the top. See, Vasudha says cold water is heavy. So when we have cold water and hot water, I don't know how many of you have observed while taking bath. So if we have cold water and hot water, the cold water settles down and the hot water is staying up. So even between cold water and hot water, the cold water, in this case, the ice which is melting, that is cold, that is going down. Whereas in the left case where the ice was melting, it is going down. Vyshnavi, maybe you can play the video again. Okay. So see the left side. Can you just highlight that part in the left? That left.
The left one.
Yes. The way it is coming down, all the melted ice, it is just coming down because the cold water density is higher. Cold water goes down, normal water stays up. Okay, so as it is melting and it is coming down, just see in the right, the ice which is melting in the right, it is staying at the top still. So just imagine, because it is cold at the top, will it may make the ice melt faster or slower in salt water? Yes, so salt is making this very dense so that even after melting, the ice is not going down. Ice is still at the top in salt water. So melted water of ice in salt water is floating, and melted water of ice in fresh water is sinking. So what does that tell us? Yes. So whoever is interested in the programs, we will keep sharing the updates. So I just get a message from Abir that congratulations for the wonderful session. The session is amazing. Thank you. I hope everybody else also enjoyed the session, that I can see in the feedback from many which ways. I'm glad that Vyshnavi, so that is all congratulations to you finally. I guess everybody has enjoyed the session thoroughly. And yeah, if you're interested in any other programs, we will keep you posted on the groups, and the mails may not be, but the WhatsApp groups, you will receive these updates as and when we have those upcoming programs. So yes, so I will not like to conclude this part, but I just want to conclude saying that we can't generalize things. Like we observed something with salt sprinkled on ice, and we all try to generalize that, okay, then even salt water will behave the same. But when we see with salt water, it's actually behaving very differently, right? So it's always good to just experiment, and it becomes even more interesting when what we predicted is not happening. So then that makes us thinking more, right? That, oh, I thought that way, now it is this way, but what may be the reason, right? So we start for figuring out the reason further and further and further till we may get the answer, or we may not get the entire answer anytime, who knows. But we still, that journey is constantly on. So science is more about this journey where we keep on finding out more and more things, exciting journey itself. Vyshnavi, I guess that's.
I still see some very interesting questions. I just wanted
Sorry.
to add that I see many of you are adding to your from your real life experiences. For example, Harshita is saying, why do people put salt in freezer foods to make them last longer in the fridge? Won't the ice in the can melt? Very nice question, Harshita, and it's nice that you are thinking from experiences that you have had in your life. So science is there all around us, right? Science is there all around us in our life. And one of you has mentioned how salt adds taste to cooked vegetables. So I would like to conclude today's session by on this note saying that science is there all around us in all our everyday things, and keep exploring. Thank you all to all the students who really made this session so enjoyable, all the teachers and the science enthusiasts who have joined us from everywhere on YouTube, on Zoom. We have enjoyed so much having all your predictions, your observations, your participation in all the different media, and hearing from all your questions. We are only concluding today's session, but please stay tuned. Join us for all the future sessions to know more about QuestFest and the Joy of Learning programs. We are looking forward to having your participation in all of this.
Vaishnavi. So I want to actually, there are a couple of hands raised, and I can see that there are, because it's student session, I want to make an exception. If we can unmute some of them and take their questions, because
Yes,
so
I will stop my screen share so that I
go
can
to the
see.
yeah. So see, this journey doesn't stop anytime, right? It's a constant journey. There are so many interesting. What if we add soil? What is this? What is that? You figure it out for yourself. These are all simple things to figure it out by ourselves. You can add soil and see which one is left, which one is right. It's very easy to make colored ice cubes and see which one is behaving in which way and why. So you may get even more interesting observations, and please share it with us. Whatever you are doing, we are all admins of this group. You can share with any one of us, and we know that, okay, our young scientists are actually exploring things further. So yes, now, well, let's take some 5-6 questions today, 4-5 questions. Sai Harshita. Yeah, I will.
Yes, sir. Actually, that question that you said, I posted in the chat box. That question is still in my mind. I can't get rid of it. And one more thing, sir.
What is the question? What is the question? What makes ice float?
Sir, that when we add lots of salt to freezer foods and then we put it in the fridge, then why doesn't the ice in the can melt? And one more question. Why do snowflakes look like crystals? They're just ice, but very small. And how come they melt faster?
What do you think, Sai Harshita?
Sir, I've heard that salt makes the food stay longer, but after the experiment, I thought, why doesn't the food go all wet? Like tin sardines, why does it get all wet and gooey?
Right. So what do you do now with these questions? That's the more important thing. What do we do with these questions?
I have to try them out.
Huh?
I have to try them out. I have to take something tin and test it.
So how do you plan to test it? See, that is very important. So now whoever is asking any question, you have a challenge with you, right? That you ask the question, but tell me, how do you plan to find out the answer? That is more interesting to me. Okay, so you can think meanwhile, Sai Harshita. We will go next to Kushal. Yes, Kushal. Ask your question and tell me, how do you plan to find out the answer for your question? Yes, Kushal. Okay, I guess he is having some problem in unmuting. Scientific gamer.
So, does intermolecular space between the molecules make the molecules easy to boil or less easy to boil?
Wow. So what do you understand by intermolecular spaces?
Intermolecular spaces, they vary between many things. In plasma, they are very, very complicated. In gas, they are very, very far. And in liquid, they are less far than in solids. And in solids, they are very tightly packed.
Okay. So now what do you think about your question? does intermolecular spaces have any role in this melting? What do you think? Yes.
I think they make it harder for us to melt. Since
Okay.
from solid it has to go to liquid, then to gas.
So when we make salt water, is it increasing the intermolecular spaces or decreasing the intermolecular spaces?
It is decreasing the intermolecular spaces.
So now will that salt water freeze faster or slower?
Sir, I have not yet, tried that.
Can you try that? What is your prediction? What is your prediction?
I think it will freeze much slower.
Why?
Since if there is less intermolecular space, the cold has less space to go inside the molecules, and therefore it will take more time for it to freeze.
Very nice. Okay, try it out and please share whatever observations you get. You can always do it with different things, not just salt. Maybe try with sugar, maybe try with something else, and please share your observations. Yeah.
Okay, sir.
All right, great. Advait.
Yeah, thank you. So my doubt is, in which temperature water is freeze to convert into ice? H2O.
What is?
So in which temperature H2 is freezed into ice?
H2O.
Yes, so water.
Water. Right. At what temperature it freeze into ice? Okay, I guess which grade you are in?
So I'm in 4th grade.
Okay. Wow. So you are not taught in the school, right? So I just saw a comment by a teacher who says that I learned new techniques for teaching science to middle and secondary classes. So see, this is how we can actually harm.
So my mother told me.
Yes, Advait, I want to really know the answer from you. What do you think? How can we find it out? At what temperature this water is freezing to ice? How do we find it out?
So my mother told me that in 0 degrees there is snowfall. So I think in 0 the H2 is converted into ice in 0 degree.
Okay, but how will you find out, Advait? See, should we believe our mother or our scientists or our textbook or no? What do you think?
Yes, so I believe so taking every glass of water and putting it in the degree if minus 10 degree of before 0 before 10. If someone freezes, that is the freezing point.
Excellent, Advait. Excellent. You just made my day, Advait. Just made my day. You are in class 4, right?
Yes,
see, so all the teachers who are here, part of this session on YouTube or even over here, just see this boy from class 4. He came up with a simple experiment design on the spot to find out how what is the freezing point of water. Very frankly, I did not have any experiment in mind so quickly, but he came up with it just in 2 minutes. But we end up just giving away the answer. He already knew 0 because somebody else told it. But when probed for designing an experiment, he came up with a simple experiment on the spot. Excellent, Advait. So you may not have all the resources at hand, but what you designed a simple experiment, amazing. Maybe you can think of a simpler one, which you can also do, Advait. And please share. I am so glad that you came up with this experiment design so soon. Who told you?
I have cutted water also.
How did you cut water?
So like cutting means to make one part into 2 parts. So I've taken a bowl and water into a plate, then put the
put the bowl on the plate, then the water inside of the bowl is different and the water outside of the bowl is different. So basically it is curded water.
Okay. Nice. Interesting. Okay. One last question, Meghna. Very nice, Advait.
So, so, so I have one more question.
Okay, fine. Quickly, you ask the question. We will not have any discussion. Yes.
So please tell in which class is correct, in which water is spreaded, or in which water is not spreaded, colored ice.
But that you can just do it for yourself and just see with the colored ice. So you just add some.
How to make colored ice?
What do you think?
How to
You
make
just take
colored ice?
take some food color in mix in water like you make for salt water. Similarly, you just make food color water and keep it in, right? Yeah. Meghna, quick one last question. And oh, sorry. Meghna? Yeah.
Good evening, sir. Sir, why is the ice made from hot water is transparent and the ice made from cold water is translucent?
Ice made of hot water is? Okay.
Transparent.
Transparent. Oh, wow. Excellent. So I guess your question is, wow. Okay. So ice made up of hot water is transparent or ice made of cold water is transparent. So can you just try this, Meghna, please, and share this photograph of these two ices which is made up of hot water, and will it make any difference? I'm just curious to know. Why do you say so? Okay, Meghna, I guess there is some audio break in your end, but that's okay.
The ice.
Okay, that's okay. I guess there's some audio break, but never mind. So I'm so happy with the questions. I guess we should just conclude this session. It's already 6:10, and I see that almost like 100 plus people on both Zoom and YouTube combined with us. So it's just so nice to see all your interest in science and explorations, questions. I just hope we get so many questions from you all during this question contest, right? See, because that's where the science all starts. It's not about the answers that we have or the projects that we do to finally find out some answers, right? It all starts at your questions. So let's start asking questions. Let's celebrate questioning. Yeah. So who all will share your questions in the question contest? Give me a thumbs up. Who all will share your questions in the question contest? Yes. See, I'm seeing so many hands up now. Great. So nice. So thank you everyone, and whoever is present from the teaching fraternity, teacher community, we will have a session soon for all the science teachers also on Wednesday, and we will see how we can take some of these components in our science classroom. So thank you everyone for participating, and we will see you all during our upcoming sessions. Thank you. We really enjoyed this session, right, Vyshnavi?
Thank you all so much. We enjoyed the session so much from all your active participation, both on Zoom and YouTube, from people of all ages, especially the students. We really enjoyed having all of you with us so much. Keep questioning, keep observing, keep exploring, and keep sharing all of these with us.
Right. So that is all for today, and we will meet tomorrow again at same time 4:30 for the next session on the secrets of primes. So that will be another very interesting session by one young faculty. So see you all tomorrow, and we have 2 sessions tomorrow, as you all know. There is another talk by a very distinguished scientist from IIT Madras. So yeah, tune in for both the sessions tomorrow then. All right, great then. Bye everyone.